In this video, we're going to use the law of sines to find the measure of an angle. Now, the law of sines can be found on our reference sheet. And as we know, it's used to do two things. One is to find the length of the side. The other is to find the measure of an angle. Today, we're going to go ahead and find the measure of an angle. Our question here says that we have triangle ABC. We are told that little a is 7. Measure of angle A is 30 degrees. And we are told that little c is equal to 12. And we're going to notice if we take a good look at the information that we have two sides. We have one side that's 12 and another side that's 7, along with the measure of one angle. If I see that I have a side, and an angle, that's my clue or my indicator that I'm going to use the law of sines. Just like we've done before, I'm going to set up a proportion. I'm going to say that 7 over the sine of 30 is equal to 12 over the sine of c. Very important. We need to make sure our pieces line up. Of course, we need to make sure that the 7 goes with the sine of 30, because they're across each other, and the 12 goes with the sine of c. Once I have my proportion, I'm going to go ahead and cross multiply. I'm going to take 7 and multiply it by the sine of c. And I'm going to say that that's equal to 12 times the sine of 30. Please remember that the sine of 30 is 1/2, so 1/2 of 12 is equal to 6. From there, I'm going to isolate my trig function by dividing both sides by 7. I would say that the sine of c is equal to 6 over 7. One of the things we have to remember about the law of sines is that it is a little different than the law of cosines, and by that I mean we could have more than one answer. Once I get my trig function all by itself, I'm going to take a look at the quadrant, the sine, and the reference angle. Didn't have to do that with the law of cosines, but it's a must for the law of sines. I know that this fraction, 6 over 7, is positive. I also know that sine is positive in quadrants 1 and 2, and what I'm going to do is use that information to find my reference angle. If I take my calculator and I go second sine 6 divided by 7, I'm going to end up with a reference angle that's 59 degrees. Well, that 59 degrees is one of my answers. That's my first quadrant answer. I have to make sure that I check to see that I could have a second answer. The second answer would be my quadrant 2 answer. To get to quadrant 2, we take 180, subtract our reference angle. That's going to give us an angle that's 121 degrees. We have to make sure that both of those answers work. Well, I have one angle that's 30 degrees. I just figured out that another one is 59 degrees. And keep in mind that the angles of a triangle. Have I left room for a third angle? Since the sum of the angles of a triangle is 180 degrees, this would be 30, 59. I definitely have room for a third. In fact, it would be 91 degrees. Now, the other potential answer is at 121. So I have to check. If I have an angle that's 30 degrees, and I just figured out that my other potential answer is 121 degrees, do I have room for that third angle? Well, if I add these two together, it's 151 degrees. 151 degrees is less than 180, so my answer is yes. If I take 180 and subtract 51, that's going to give me 29 degrees. So both of these answers have checked out, and in fact, they're both correct. Second example, same basic idea. We're going to go ahead and draw our picture. It says here we have triangle ABC. We're told that little a is 15, measure of angle A is 30, little c is going to be 12. Just like we did before, I'm going to see that I have two sides. I have a side that's 12, I have a side that's 15, and I have the measure of one angle. If I have that, I have two sides and one angle, side angle, I'm moving towards the law of sines. I'm going to set up my proportion. 15 over the sine of 30 is equal to 12 over the sine of c. Once I have my proportion set up, I'm going to cross multiply. I'm going to take 15 and multiply it by the sine of c. So 15 sine of c, and I'm going to take the sine of 30, multiply it by 12. Sine of 30 again is a half of 12 is 6. I'm going to isolate my trig function by dividing both sides by 15. The sine of c is 6 over 15, which if I reduce it, is 2 over 5. Just like we did in the last question, once we get the sine of c all by itself, we have to make sure to check to see how many answers we have. I'm going to take a look at my quadrant, my sine, my reference angle. This fraction is positive. Sine is positive in quadrants 1 and 2. Again, I'm going to use my calculator, second sine 2 divided by 5, to find that reference angle. Reference angle in this case is going to be 24 degrees. Once I know that that angle is 24, I have to check my potential answers. My first quadrant answer is that 24 degree answer. My second quadrant answer is 180 minus 24, which is 156. Now, before we move on, we have to make sure that they both work. Well, if this angle here is 30 degrees, we just figured out that angle C could be 24. Well, if I have that's 30, that's 24, do I have room for angle B? The answer is yes. These two add together to be 54, plenty of room before we get to 180, so that 24 degrees I'm going to say is going to work. Now the question becomes, what about 156? Well, if this angle is 156 degrees, and the other angle is 30, Can I have one that's 156 and 30? The answer is no, it's too big. So the 156 we're going to reject. And we're going to say that our only answer for this question is 24 degrees. First example, we had two answers that worked. Therefore, really two triangles. And then in the second question, we had one answer that worked. So that left us with one. And we're going to see that same kind of question come up in this example. It says, the wording of different. It says, how many different triangles can be constructed? Now that is automatically going to be a law of sines question. If I read that, I'm going to think law of sines, and I'm going to find the measure of an angle. And I'm going to draw my picture. I'm going to go with triangle ABC. I know that little a is 5, little b is 7, and the measured angle is 30. So once again, if I take a good look, I'm going to notice that I do have two sides and one angle. That angle is going to lead me to the law of sines. Set up my proportion. I'm going to say 5 over the sine of 30 is equal to 7 over the sine of b. All right, once I have my proportion, again, it's cross multiply. I'm going to go 5 times the sine of b is equal to sine of 30 times 7, which is going to be 3.5. Once again, I'm going to get the sine of b all by itself, divide both sides by 5. The sine of b is going to be equal to 0.7. A little quadrant sine reference angle. This decimal, 0.7, is positive. Sine is positive in quadrants 1 and 2. And to find my reference angle again, second sine, 0.7, I'm going to end up with a reference angle of 44 degrees. Once I find that 44 degrees, I need to make sure I account for the fact that I could have a second quadrant answer as well. So one potential answer is 44, the other one is 180 minus 44, which is 136. Just like I did in the last question, I'm going to make sure that they work. If I have an angle that's 30 and I have an angle that's 44, do I have room for that third angle? The answer, of course, is yes. These two angles, 30 and 44, add together to be 74, so I have plenty of room for that third one. Same thing here. If this angle is 30 degrees, and I just figured out that it's 136 degrees, do I have room for a third angle? Once again, since 30 plus 136 is 166, I do have room for that third angle. Since both of these angles work, the answer to the question, again, the question saying, how many distinct triangles? The answer to that is going to be 2. Our last example is going to follow the same kind of a flow. It's going to ask how many distinct triangles can be formed. I'm going to start by drawing my picture. I'm going to call it triangle ABC. If I look at it, little a is 10, little b is 12, and angle B is going to be 20. Once again, it says the total number of distinct triangles. That's my first clue that it's going to be a law of sines question. So I'm going to set up my proportion. I'm going to say 12 over the sine of 20 is going to be equal to 10 over the sine of A. Once I have that proportion set up, I'm going to cross multiply. 12 times the sine of A is going to be equal to 10 times the sine of 20. I'd like to get the sine of A by itself. Divide both sides by 12. Sine of A is equal to, when I plug all that into my calculator, I got 0.28501. 67861. I'm going to take that shortened a little bit. I'm going to go to 4 digits to the right of the decimal point. As long as you go a minimum of 4, you should be fine in terms of the accuracy. From there, I'll go a little quadrant sine reference angle. Again, that decimal is positive. Sine is positive in quadrants 1 and 2. To find my reference angle, again, I'm going to use my calculator. I ended up with a reference angle of 17 degrees. That means I have a potential answer of 17 degrees, and my second potential answer is going to be 163. The question becomes, do they both work? Well, if I have this angle here that's 20 degrees, and this angle here that's 17, do I have room for a third? The answer is yes. The sum is less than 180 degrees. Now, likewise, if I check this 20 degrees with this angle that's 63 degrees, it's just too big. This one does not work. Since only one answer works, the answer in this case, in terms of how many triangles, is that. Now, the law of sines can be used to find the length of the side, the measure of an angle, and again, occasionally we're going to see a question that says how many distinct triangles. If I see how many distinct triangles, it's always going to be a law of sines question.